Our Blues are amazing athletes. Relentless practice strengthens their bodies and trains their brains.
With practice, various areas of the brain develop stronger connections with one another. The lay term for that might be muscle memory, but the more up-to-date term that we might use is something called functional connectivity, where certain areas of the brain strengthen their connections with other areas of the brain, and through that process become more efficient, taking tasks which are cognitively challenging or very complex and streamlining them and making them as efficient as possible.
Even though a hockey player's brain is built the same as yours, does it act differently? Let's take a look.
Over the last number of years, we've had some really amazing technology that we can use both in the clinical setting and the research setting. What these tools allow us to do is to be able to measure how neurons fire in response to certain stimuli, and we can actually measure areas of brain activity in response to certain stimuli. This is very complex, high-tech stuff, but we're really gaining some tremendous insights into how the brain works when tasked with a certain process.
This is a functional MRI machine at Barnes Jewish Hospital. We're going to compare the brains of a blues player and a non-athlete.
Functional MRI allows us to study which areas of the brain are most tightly connected with other areas of the brain. We would anticipate that in a trained athlete, that certain areas of the brain are going to be more tightly connected to each other than in the brain of an untrained athlete.
We asked the player and the non-athlete to think about making a slap shot.
All right, Jax, what I'd like you to do is to start thinking about you approaching the goal and taking a shot at the upper left corner.
I think what we're going to be able to see is that for someone who has had a lot of practice doing a particular task, the area of the brain that lights up is going to give us a stronger signal in the player's brain than the signal that we'll get from an untrained player's brain.
All right, John, what I'd like for you to do is imagine you taking a shot on the left upper corner of a hockey goal.
That signal correlates with their ability to do this task more efficiently and quicker than an untrained person.
So what did we find out?
If we look at these scans of the athlete versus the non-athlete, what we can see is that the areas of the brain of the athlete are lighting up much more intensely than the areas of the brain in the non-athlete. In addition, what we'll see is that there's different areas of the brain that are lighting up in the athletes compared to the non-athlete's brain.
Why is there a difference?
What we're seeing here are the end results of practice. And so with practice, certain areas of brain get used to working together to execute a motor program. These tools add to our ability to take care of our patients. When a patient comes into the clinic room and they describe what their symptoms are, we perform an exam and we have a good deal of understanding about, based upon neuroanatomy, what might be going on. But these additional tools give us additional detail. They allow us to peer inside the brain. They allow us to look to see if all the structures of the brain are intact. And the technology that's coming and is in development allow us to see if those pieces are actually working together the way they're supposed to.
We aren't all professional athletes, but we can train our brains to perform like theirs. That's pretty cool.
Neurology is fascinating. It encapsulates what makes a person. Each and every day we get a chance to interact with people that are going through their own various struggles, and bringing these tools to bear allows us to understand their situation better and allow us to try to help them as best as we possibly can. When I watch sports, even as a neurologist, with a lot of understanding of how the brain works, I still am in awe of what I'm seeing in front of me. And just the idea of what a human being is able to accomplish is a source of endless fascination.
Wrap your brain around that. And that's the science of St. Louis Blues hockey.